So when we talk about molecular shape, molecules obviously occupy space, right? They are a thing. Well, when molecules form, depending on what electrons they have and what electron suborbitals are filled, they make certain shapes. Okay? And we'll learn about the shapes, and then we'll go back and connect how the shapes connect to the orbitals. All right? So the molecular shape, there are multiple different kinds. We're going to start off with the simplest kind, which is linear. Okay? A linear shape, you understand what that means. It's a line, right? So a good example of a linear shape molecule is CO2. Oh, I'm going to change this. There we go. So you can see it better. CO2. Okay? When we look at the shape of CO2, we have a carbon in the middle. What the heck, mouse? You have a carbon in the middle, and then on both sides you have oxygen that is double bonded. And it makes just a nice little line. Okay? So the way that we can draw that so let's do carbon is black, because in organic chemistry, carbon is black, like coal. Okay, and then bonded on the side, you have two oxygens. Okay, you've got one oxygen over here, you've got second oxygen over here. Okay, beautiful. Very simple, all right? A linear molecule. Makes sense. Okay. Now, let's look at another example. This time with a little bit more nuance. Bigger and longer. Okay. So now let's talk about bent molecules. Molecules. So a bent molecule, an example of a bent molecule is very, very common, something that you interact with every single day, and that is H2O. Okay. Dihydrogen monoxide, water, right? Water has a shape that looks like this. So if we were to draw the letters, we have an O in the middle. And then coming off the sides, we have an H and an H. So why is it that this molecule makes a different shape than carbon dioxide? They both have 3 atoms, right? The reason is that there are 2 free electron pairs that hang out over here. 1 electron, 2 electron, 1 electron, 2 electron. And they repel the electrons that orbit the hydrogens. So we get this shape. Okay? If we were to draw that in a way that would fill space, we have the oxygen in the middle. We're going to use yellow for hydrogen. The hydrogens are off to the side here. 1 hydrogen, 2 hydrogens. So far, the molecules that we've been looking at fill three-dimensional space, but their shape is only two-dimensional. Okay? My drawings are about to get much prettier. And by prettier, I mean horrific to look at. Disgusting, yes. Terrifyingly bad. Okay, so bent molecules. Now, if we look at the next type, let's talk about tetrahedral. Actually, no, let's leave the tetrahedral for later. Let's talk about trigonal planar. Because trigonal planar if you were to guess what trigonal planar means, or what the shape of a trigonal planar molecule would be, what would your guess be? Anyone? No. Anyone? Anyone? Anybody? Something with three. Yeah, for sure. Okay. With three sides, yes? Yes, Mr. Crochet. Okay. So an example of this type of molecular geometry or molecular shape would be boron trifluoride, BF3. You've heard of BFF, but have you heard of BFFF? The fun times. Best fun friend forever.
Best fun friend forever?
Yeah. Best, oh, here we go. I have a BFFF, a best female friend forever. There, that's my wife.
Oh.
Yeah, everyone's heart melted just a little bit. And you, at the same time, you also threw up a little bit in your mouth.
Yeah.
What? What a loser. You haven't even met my wife. She's a lovely person.
I'm sure she is. You're just a loser.
I feel like a winner, so
You should feel like that.
I feel like a winner, so I don't know why you think I would be a loser. Okay. So the way that we can write this out is we do a B in the middle, and then we have boop, 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 a fluorine on each side. Okay? Boron trifluoride. If you want to look at a much better representation of what that would look like, it's like this. Looks like a Kirby. It looks like Kirby had a limb amputated. Poor Kirby. Kirby hiding in the ball pit. Okay, so once again we're gonna use black for boron. Okay, boron's gonna be black in this example, and we'll use blue for fluorine. So we have one here. One here, and one here. Beautiful, Mr. Crowshaw. Yes, I know. Thank you. Stunning, yes. Boron trifluoride. Okay. Now it's going to get a little bit more complicated. Okay. Let's talk about tetrahedral molecular shape. I don't know what's more work, using like typing this out or just writing it with the cursor. Tetrahedral shape. Okay, tetrahedral molecules. We're gonna come back to our good old pal, methane, CH4, or carbon tetrahydride, right? But the common name is methane. You can say carbon tetrahydride. I will understand what you're saying, but we usually just say methane, okay? This, it's a wee bit more complicated. If we do a wee bit more complicated, if we do a C in the middle, and we have an H coming off the top, I'm going to use a shape that you haven't seen yet. We're going to use a triangle. And you're going to be like, whoa, what the crap? A triangle.
Why is a triangle Earth more popular? That's way funnier than flat Earth.
A triangle Earth? A pyramid Earth? Okay.
It's flat. It's like shaped like a triangle.
So we have two triangles. That is not a triangle. That's more of a rectangle. Yeah. Okay, that'll work. We have a triangle here. H and H. Okay, and then we're going to do one more, because how many H's should there be? There should be 4 H's, right? Well, right now we only have 3 H's. So what we do is we go little line, slightly bigger line, big-ish line, H. What does that even mean? Well, the triangles indicate that the atom orientation is coming toward you. This is a cult. Yes, this is the honorary cult of Croshaw, where Croshaw is the center and his honored students. Yeah, it's the honorary students and the humans. There you go. We have Croshaw, and then we have the humans surrounding the Croshaw. What? So the little lines mean that the atom is going away from you. Okay? I am going to attempt to draw this, and it's going to be very ugly. Okay? I'm going to attempt. Yeah. Whoa, sorry. Okay, so let's look at this. So we've got a carbon in the middle. Okay. And then we have, what color did I use for hydrogen before? Red?
Red. Wait, no.
No, we use yellow. Oh my goodness. Yellow. So we have one here on the top. Kind of on the top. And then we have 2 that are here. And here. And then there's one back here. You can just see like the bottom of it off the side. I'm going to attempt, that's my attempt. You got to remember, I'm using a mouse and a thick, whatever, cursor. If we look at this in a much better way, it looks like that.
That seems less complicated than what you tried to do.
So here's the carbon, and the hydrogens around the carbon. Okay? So that's what it looks like if we write it out. This is Mr. Crochet's very, very poor representation. I tried. Thanks, Trinity. Thanks, Trinity. Okay. Tetrahedral. All right. One more. Now we need to talk about trigonal pyramidal. Okay. So we've looked at all these different things that are going on. What would your guess be on a trigonal pyramidal?
It's a pyramid.
A pyramid, yeah.
Which has 4 sides.
A pyramid has 4 sides. What would trigonal mean? A 3-sided pyramid.
What is that?
A 3-sided pyramid. We're gonna do.
Yeah, that's
Well, a pyramid has a bottom and then 4 sides.
or 3. I was thinking 3 sides at the bottom, which would be 4 sides. Or you could like take it.
So a trigonal pyramidal is a pyramid with 3 sides and a bottom. Okay? An example of this would be NH3, which is called ammonia. Or nitrogen trihydride, right? It has a trigonal base. So it's going to look very similar to the tetrahedral, just without something coming off the top. So we have an N. And then off of the side, we have a triangle here, H. Off of this side, we have a triangle. Dang it, why is that side always like rectangular? H. And then we get in the middle, the dotted line triangle, H. I'm not going to try and draw this one because you guys made fun of my last one so brutally. Okay, look at this. This is what it looks like. Yeah.
So beautiful. That one looks like.
So this is called a spatial or 3D rendering. This, let's see here, this one's actually better. This is a ball and stick representation. This is ammonia. You've got the nitrogen in the middle, 3 hydrogens all around the outside. Around the outside, around the outside. What? I should draw it for you? You're just trying to make up for the fact that you made fun of my last one? I'm just kidding, Shelby.
I didn't make fun of your last one. Just for the fact you have a wife. That's way
I made fun of the fact that you have a wife. I feel like one of these things is worthy of making fun of someone, the other one is not. I'll let you figure out which one's which.
Yeah.
Jokes are you. I can't think of I'm so confused.
All right.
I'll never figure it out.
So that's molecular shape. For those of you watching at home, that's all I'm going to talk about in the video because I'm tired. I want to take a nap. Yeah. Okay. Goodbye.
You have to say like and subscribe.
Yeah, like and subscribe or whatever.